Hello world, what is going on? Welcome back to the channel, and today we'll be seeing the easiest problem on the Codility lessons, and we will see here an easy solution using math instead of using the naive approach, which would be calculating all of the iterations. That's why this section is called time complexity. So let's just get at it. Okay, so as always, let's go to Codility/programmers, in this case lesson 3, time complexity, and let's go ahead and read the problem description of FrogJmp. Let me select Python here, and it says, a small frog wants to get to the other side of the road. The frog is currently located at position X and wants to get to a position greater than or equal to Y. The small frog always jumps a fixed distance d. Count the minimal number of jumps that the small frog must perform to reach its target. So write a function that, given three integers x, y, and d, returns the minimal number of jumps from position x to a position equal to or greater than y. For example, given x equals 10, y 85, and d 30, the function should return 3 because the frog will be positioned as follows. After the first jump, 10 plus 30 equals 40. After the second jump, 10 plus 30 equals 70. And after the third jump at position 10 plus 30 equals 100, which is greater than 85. So it says here, write an efficient algorithm for the following assumptions. X, y, and d are integers within the range 1 and 1 billion. And x is less or equal than 1. So it's important here to see that they're asking us for an efficient algorithm, and let's look at the range because all of the values are between 1 and 1 billion. We should always take a look at the worst case scenario. In this case, x would be 1, y will be 1 billion, and d will be 1. So in that case, if we do an iterative approach, it would take 1 billion cycles, which is 10 to the 9, and that exceeds the usual time limit for iterations, that's 10 to the 8. So that would be the naive approach. We can just have a for that iterates 1 billion times. That's just too much. So let's go ahead and understand the problem to see what the mathematical solution is. Then we'll run in all one time because it's just a simple operation. Okay, so we have here a simple representation of the operations that will be taking place. So the frog will start at x, it wants to get to a position equal to or greater than y, and it will perform n jumps. We need to determine what that n is, and on each jump it will jump distance d. So the simple explanation here, mathematically speaking, is to grab the distance between y and x and divide it by d to know how many jumps it will take to reach from x to y or more than y. So let's take into consideration here a small detail, that is that this division will not exactly be an integer number on all cases. So in this particular example it will be like, I don't know, 1, 2, 3, 4, 4.7, but the frog doesn't jump 4.7, it jumps integers. So we need to get to the next biggest integer, which would be 5 in this example. And to do that, we're going to use the ceil function, which will round our division to the closest biggest integer. So let's call this. Okay, so we're back here at Codility. Let's go ahead and start this test. Let's select Python. Let's get rid of all of this. And since we're going to use the ceil operation from math, let's go ahead and import that. So from math, import ceil, and let's just return ceil, and we're going to subtract x from y and divide that by d, and that should be our solution. Let's test this. It seems to be working. Let's go ahead and submit the task. Okay, and we got the results back. As we can see, we got a 100% task score and 100% correctness score. And we can see here that the detected time complexity is 0.1 because it doesn't matter what the numbers are, it will always run in constant time. It's just a mathematical operation, and even for large test cases, it runs really fast. Okay, so that was it for this exercise. It's a really simple exercise. The main key point to take away here is that just using a mathematical operation we can avoid unnecessary iterations. And that's pretty much it. If you liked the video, please hit the like button, subscribe to the channel, and share it if you think it will be valuable for someone else. I'll see you on the next video. Bye.